This is my lab 3. My name is Arvinder. So the first A part is what does it mean for an arc to be consistent? So basically an arc is consistent if for every value of x there exists a value of y which satisfy the constraints. And B part, what does it mean for a network to be arc consistent? So all arcs between variables are consistent, meaning for each value of one variable, there exists a consistent value in other connected variables domain. Let's move to the C part. What are the possible outcomes of the arc consistency algorithm? The problem has no solution. The domains of one or more variable are reduced because inconsistent values are eliminated. No further elimination can be made, meaning the problem has achieved a consistency. If a domain is reduced to an empty set, the algorithm detects inconsistency. Let's move to the second part, and there is a D part. Consider the CSP below. If you run a consistency on this CSP, will the domain of an arc of the variable get smaller? No, the variable will not reduce after running a consistency because every value in the domain of A, B, and C already satisfies constraints. So our constraints our in this problem is B is not equal to B is not equal to C, and B is not equal to C. So for the first arc A, B, with A is not equal to B, if we take A equal to T, B must be F, and for A equal to F, B must be T. This constraint is already satisfied the domain of A and B, so no values are reduced. Similarly, the domain of A and C as well as B and C are considered, so no values need to be removed. Let's move to the E part. If our consistency finish all the variables have multiple values in their domains, is there guarantee to be a solution? Why not? So basically, the answer is no. Our consistency doesn't guarantee a solution, even if the variables will have multiple values in their domains after applying it. It basically checks the conflicts between pairs of variables connected by a constraint, ensuring they don't conflict with each other. Let's move to the F part. Create the CSP in AI space and run our consistency. Verify whether your prediction in question D was correct. Let's move to the AI space. Let's start. First, it takes, there are three domains A, B, C. Three of them have the two values T and F, and the constants are A is not equal to B, B is not equal to C, and A is not equal to C. First, it takes both the values T and F. For both the values, it is satisfied, but for the value T, it doesn't. So basically, we unable to find any solution. So basically, if A for when our consistency is applied over here, if A is T, both B and C must be F to satisfy the constant, and if A is F, both B and C must be T to satisfy the constant. This work fine for two variables, but there are three variables. It creates a contradiction. If A is T, B equal to F, and C equal to F, but B is not equal to C, requires B and C to be different. But if A is F, B equal to T, and C equal to T, which again violates B is not equal to C. Because of this, no valid assignment satisfy all the constant. Basically, we don't get any solution. No solution.